Okay, in this video, we are going to be looking at how to create our own custom devices in VHDL and then connect them into the Microblaze CPU. So we're going to do very simple examples right now. We're going to look at using the DIP switches on our FPGA board, and we're going to look at using the LEDs. This time we're going to make our own interface. We're not going to use the built-in items that I showed in the previous example. To get started, we'll need two files. One for the switches and one for the LEDs. Okay, so this file I already wrote out, the VHDL for the DIP switches. I'm calling it DIP unit, and I have an input and an output. The input, I am calling it DIP board. The board is, this is the data that is coming from our board. It is the external piece of information. So switches are inputs, so it's going to be on an input, and I have 4 of them. So I have it as a vector of 3 to 0. So we're going to be flipping the switches up and down on the board, but that data has to go into the CPU. So the output of this unit, I'm calling it data CPU. So this will be the binary value we send to the CPU. And the code is just simple, connecting data CPU to DIP board. LED is going to be similar. This time, our CPU is going to tell us what values it's going to want written to the board. So the input here is the data coming from the CPU. Our output would be the LEDs that will light up on the board. So I have these two files, and we'll be using them as we make our own custom interfaces. So we're going to get started. Let's close this project out. I just have this project just to create these two files. I'm going to create a new one. Find a place to store it. So this will be an example. SoC. Let's do the LEDs first. Let's write it as example LED. All right, so it's an RTL project. We hit next. Hit next. Our board is the RD. All right, what we're going to be creating is a custom IP core. So to get started, we're going to go under Tools, Create and Package a new IP. We're going to be creating a new AXI4 peripheral. Yeah, we got to give it a name. This is our LED, so we'll say it's example LED. Description, testing, LED. Right now, we can leave all of this data standard. Later, as you do more advanced items, you may want to change the number of registers. The registers is how your CPU will write into your custom interface. The default is 4. All we'll need is just 1 in this example. All right, we're going to create it. What's our next step? We're going to want to edit the IP. All right, so this thing loads up. And we'll see that we'll have two files. Okay, what we'll need to do is add in our source that we already have. So we're going to be adding in the source. I have the file already. I put it in this folder here. We are doing the LED, so I'm using the LED unit. All right, so we can see that we have our item here. Okay, so let's see in the IP custom items, we have two files that were created for us. This is in a hierarchy. This is the first unit. This gets included into the second unit. What we're going to need to do is have our LED be the last item in this unit. So we're going to have to include it so that it feeds into the system. All right, so I'm going to take this entity. I'm going to copy it because we'll need this information. I'm going to go to this unit here, which ends in AXI. So we see this AXI already has code for us. We see we have an entity. It says, okay, user to add ports here. Don't modify signals. Then it has an architecture section. And it says, someplace in here should have, we can add in user. So we'll be able to add in user items here. I don't see, it has a comment to say where users should add in. But we'll be connecting it to here. So let's just do it at the bottom part. Okay, so what we're going to be connecting in is this LED unit. So this will be an item I want to add in. Now, we don't add entities, we add components. All right, so we have this component of LED unit. All right, so we have that item. Okay, so we're going to add this component into this file. So we'll just make a label for it. And what we're going to do is have an LED unit. I'm going to do a port map. And in this port map, I'm going to have two items. One is data CPU is going to have a connection. We'll figure out what the data is in a next. And then we're going to have LED board have a connection as well. Okay, so we have data coming from the CPU, and then we're going to have data leaving this unit and going to a pin on the board. Okay, so the data coming in from the CPU, we're going to write data into a register. So if we scroll down a bit, we should be able to see the names of our registers. So we have register 0, 1, 2, and 3. We're going to work on register 0. I'm going to take that, I'm going to copy it. That is what I would have connecting in to data in. Now the item is going to be that all registers are 32 bits. I will not need 32 bits of data. I'm only going to need the 4 bits. So let's just look to see how slave register 0 is defined. And they're defined from high number down to a low number. So we'll need bits 3 down to 0. So I'm only going to need those 4 bits. Now on the LED board, I have to have data leave this unit as a pin. I'm going to write it out as LED pin. Okay, LED pin is something new that we have added in. I got to create it someplace. Where I'm going to create it is, I'm going to go all the way up to the entity. I'm going to put it in the entity because it needs to leave this unit. So we will have LED pin. We add it on. That is an output. And it's a vector. And it's 3 bits of a vector. Okay, so we're done modifying that piece. Next, we got to move up 1 level. So now we see LED unit gets included into the one that ends at AXI. Then AXI is going to come into this top unit. That's just example LED. The key items is when we make this connection from here to the next level above it, the key items I need to worry about is what I added into the entity. So what I added in on the entity was this LED pin. All right, so let's go up to the next unit. We scroll down. We see, okay, here is that AXI piece. We're going to be port mapping into it. Well, I added something into here. I added in LED pin. So if I added a value onto this entity, I need to include it. I got to include it into a new statement. I'm going to call that LED pin. So LED pin is connected to LED pin. Well, where is this LED pin going to be found? Right now, it's undeclared. That's something I have to add. Now I'm going to add it to the entity of the top unit. So I just keep pushing items out. So I have LED pin as an output. That is 4 bits. And we can save that information. All right. Now we're going to go to this package IP item. And we're going to look at items that do not have a check mark. So identification is check mark, compatibility has a check mark, fire group. We're going to merge changes, custom parameters, merge changes. We get to the final step. And we're going to hit this repackage IP. And at this point, we are done with that step. All right, so we're going to go next. Then we're going to create a block diagram. Okay. And under the settings, we want to make sure that the IP repository is showing our project. If not, add it to this list. And let's just make sure it's there. And we'll see that we have our LED. All right, so we'll end here. And we'll do this, a similar item for our dip switches. So let me pause the video, collect everything together, and then I'll come back. All right, so now we're gonna create the IP core for our dip switches. Create a new project where we're gonna save it. RTL project. No files to be added at this point. The RD board. All right. Same item, create and package a new IP. Creating a new peripheral. Example, dip switch. Okay. We're going to leave this data the same, and we're going to edit the IP. All right, so we're going to add in our new source, which was our dip switch file. All right, so if we expand out, we see we have a top level, a lower level, which ends in that AXI, and then our dip switch. Okay, so we're going to do a similar item. We're going to go into that lowest level. We're going to add our file as a component. All right, so we added the component, and I add it, and I'll do the part mapping. The dip unit is going to be port map with a dip board being connected to something. And then data CPU also being connected to something. Okay. The dip board, that's going to come outside from our FPGA switch. That's going to be a pin for us. So we'll call it dip pin. So I'm going to add this. I got to put it in the entity. So I'm going to go up. Going to add dip pin as an input. Standard logic vector 3 down to 0. All right, so we take care of that. Now we got to see what we're going to do with data CPU. I got to send that to some value. For right now, what we're going to do is we're just going to create a signal. And I'm going to call this my data as a dip. And I'm going to want this to be the same size as a slave register. So I'm going to copy the information about the size of the slave register. So that I know my data, the dip, is the same size. So data dip is what it connects onto. I only have 4 bits of information. So I'm going to write it to the bottom 4 bits. All right, this data dip, that is the value that the CPU needs to read So we're going to modify and just overwrite slave register to be this data dip. So we're only going to look at when we do a read. So we're going to go down. And we'll see it'll have a section that says implement memory map register, register select and read for logic generalization. We're just going to comment this item as slave register 0 and write that as our data dip. So we just say, when you need to read slave register 0, use this piece of data. Okay. Now we got to go to the top level. And the top level is going to be where we're going to modify the entity. So I'm going to copy this again. Go to the top level, entity. I'm adding in this data pin. Going to go down to where we do the port map. Data pin is assigned data pin. And we can save that. All right, so we save everything, go to this package. Merge changes. Merge changes. And then we're going to repackage. All right, and let's just make sure we see that it's been added. Yep, we see the dip switch. All right, so we'll stop the video here. I'll come back in the second part and we'll look at using these two units.